So hi and assalamualaikum. My name is Siti Nurjannah binti Abbas. So today I will present 7 individuals which is from SRT605, which is Statistic in Sport and Behavior Science. So let's start it. So first is a question 1. So Ikmal want to identify any significant difference in mean of cholesterol level between group A and group B. So from this table we can see the data required is for independent variables, which is a group. We can say a group A and group B, and then after that is a dependent variables, which is we can put cholesterol level. For observations, we can see this one is independent sample, or we can use method independent t-test. And then next is a distribution of data. For this one, we use a test. Method we using is a test normality. We use a Kolmogorov, Smirnov, and Shapiro wheels. Alright, proceed for hypothesis. It's a null hypothesis (HO). There is a no significant in mean of cholesterol level between group A and group B. And H1 is there is significant in mean of cholesterol level between group A and group B. For level of significant alpha is 0.05, right? So alright, we proceed to assumption. For assumption, cholesterol level dependent variable is a numeric data, and then a random sample. So two samples are independent of each other. So group A and group B are actually independent observation. So open your SPSS. Then you key in for the column for names is cholesterol and group. Then proceed with decimals. Cholesterol 1, group 0. And then for value, actually for group, you need to key in value 1. You label A. And then value 2, label B. To measure. So group, click for nominals. Open your data view, and then you key in the all the column for cholesterol, and then proceed for group column. And open analyze. Open click descriptive statistic and click explore. Then for this one, cholesterol, you forward to dependent list, and then group for factor list. Then click statistic. Then click outliers. Proceed with continue. Then click plot. Program. And then click normality plot with test. Then click continue. For option, just no need to change. Then and bootstrap pun no need to change. Then click OK. Then you will find in output. Open for test of normality. For test of normality, we using a Shapiro wheel because a sample size is not more than 50. Then from a statistical technique, we can see a p-value Shapiro wheel from group A is 0.332, which is more than 0.05. So you can say it's not significant, it's normal. Then for group B, we can see we look for p-value Shapiro wheel for group B is 0.893, which is more than 0.05. So it's same like group A. It's not significant, and we can say it's normal. Alright, we proceed to a graphically graph. Both graphs show normal distribution, so assumption is met. So because its distribution is normal. Alright. Okay. Open your data view and then click analyze. Compare means. Then click one with ANOVA. Cholesterol just put into dependent list, and group for factors. And then you click sorry, one more time. Click You click compare means, then independent sample t-test, and then for cholesterol put into test variables, and then group you put into grouping variables, and then you click define group because we need to change to the name it group 1 you put 1 and group 2 you put 2. Show a new data. Then we proceed for this one. That we're using is dependent t-test, right? So the p-value is 0.146. Is obtained from a Leeuwenhoek test is greater than 0.05. So it shows that equivalence assumed. So for the conclusion is group A mean is 6.227 and standard deviation is 0.3901. It's reported had significantly higher cholesterol level than group B, which is their mean is 5.533 and their standard deviations 0.6144. And then it's T18 and equal with 3.074 and p-value is more than 0.05. Alright, next we proceed to the question number 2, which is data sets 2 underscore scars. So it's kind of want to compare the changes of scar area of burn patient before and after treatment. Measurements are taken 1 day before and 1 week after treatment. So from this we can see data required from which are from this we look for data required they give is dependent variables. We put a scar area of burn patient. Independent variables we put measurements before and after treatment. Observation we put a dependent sample and we use a method parrot t-test. For distribution of data, we look at test normality. We using common graph Smirnov and Shapiro wheel. We go to hypothesis. Not hypothesis, which HO, there is no changes of scar area of burn patient before and after treatment. And H1 is there is a changes of scar area of the burns patient before and after treatment. So alright, remember level of significance is alpha equal with 0.05. So assumption for this one is the observation difference before and after normally distribute. So key in name for this column is before and after underscore treatment. Proceed with decimals to measure. Just proceed with scales. Data view and you key in the numerics number for before treatment and after treatments. And then after that you click transform, click compute variables, then in column target variables you put difference, then click type and labels. So for the next column for numeric expressions, open before underscore treatment and then click the symbol minus and then click after treatment, forward after treatment, and then you click OK and change will appear in front of you. Difference we already compute. You see the difference between before and after treatments. Variable view. So it show a difference too in that column. Both before and after is 8. Difference we will show up for 12. Alright, after that click analyze, click descriptive statistic and click explore. Different you forward to dependent list and then click statistic, click outlier and proceed with continue. For plot just click histogram and normality plot with test, click continue, then proceed with OK, and then it will show up to your screen. Test of normality. For test of normality, since the p-value difference equal with 0.133 is more than 0.05, so we can say is data is normally distribute. For the graph, as you can see, the results show that the difference was approximately normal. So all other assumption is fulfilled. If we want to find the parity test, click analyze, click complements, and then click pair sample t-test, and then it show the table variable 1 and variable 2. Then you click for treatment in variable 1, and then after treatment into variable 2. So before treatment and variable 1, after treatment variable 2, then click OK. So after that it will show up something like table, and then okay, it show up like this one, t-test, pair sample statistic. So pair 1 before treatment and pair 1 after treatment. So this one is a parity test. Okay, we proceed for report of result. This one is the changes in the average scar area of burn before and after the treatment. So we put tables, scar of burns before and after. So before mean for before scar of burn is 5.3750, and after for after scar of burn is 4.0500. Then for the T is a 10.025, and difference is 19. So P is a 0. So the conclusion is they have a changes of scar area of the burns patient before and after the treatment. So we can conclude that the treatment can reduce the mean scar of the patient. So that's all from me, and thank you very much.